Hello everyone, I'm gonna show you today simple procedural modeling with Houdini. I'm gonna show you some few tricks, and we're gonna make a bridge, a simple bridge that is a simple object but quite complex if you want to control every parameters. So let's go. Okay, this is the default layout. I'm gonna give a bigger place for the network view. Okay, I press P that I can display and change parameters. P. Okay, on this side. First thing to do, we are going to build an object. So this is a volume. It's a geometry. So first node will be geometry. Call bridge. Okay, let's dive inside that node. Double click. Now we are inside the scene objects in the bridge geometry. Okay, to make a bridge, we're gonna start with the curve of the bridge. So the best thing to control the curve is to have a curve editor. So let's make a line. In general, it's a good idea to start with like a skeleton aspect, then making polygons or maybe not polygons, but maybe nerves or whatever. But the main aspect is to build some very simple shapes that we will extrude or whatever later. So this is the line that will be our bridge. We could build vertically, but it's not very visual. So let's give, for example, the z-axis. Okay, z, this one. So the line of vector of 0, 0, 1. Okay. You can display points there and point numbers there. So here is our line with a length of 1 and 2 points. We want to center the line on the origin. Maybe it's not necessary, because if we let the pivot points at the origin, maybe in one of the side of the bridge, it's maybe easier to put the asset later in a real-time engine or another 3D software. So it's as you want. If you want to set the position of the line center on origin, you have to move the line on the z-axis with a value of negative z, and the value is half of the length. So we take the length, right click, copy parameter, and change the origin x, y, z, right click, paste relative reference, slash, that is dividing, -2, line all the time. Okay, that is a simple principle, but very useful. So if you want to be procedural, you all the time try to link parameters between some nodes and others. And so the right click, copy parameter, and right click, paste relative reference, is used very often. Okay, so I have my line and I want to give it the shape of my bridge, a shape that I want to control to be changed. Um, so I have to add points. The best way to add points is to resample. So let's add a resample node. There I can change the resampling by segment length. Okay, but maybe I prefer to change this to the number of segments I want to subdivide my line. Okay, maybe 8, maybe whatever you want, but it gives you full control over subdividing this line. So now we want to offset each point vertically. So on the y-axis, we want to offset their position. So maybe we could write expression. Maybe there is 10 ways to do the same thing, but I think the more efficient is to make a point VOP right there, and maybe call it curve control with the node selected and C key. You can display a color palette, so you can change the tint of the node. Maybe it's important for us to the value inside this node are very important, so we could find it more easily in the future. C shortcut is C, like color. Okay. Let's continue. The attribute VOP is a node network that can change each point, each primitive. Right now I want to change each point position. So let's double click on curve control on this attribute VOP, and let's see what we have. We have on the here on each side the input, and on the other side the output. We can gather data and set data. So there I can change my point position by splitting this green dot. Green means that we have a vector. We can split this making a vector to float. So I press tab, then vector, and I find vector to float. That's splitting my vector in 3 float. I can do the same right here, or maybe I can offset my vector with a up vector. That's the same. I try to show many things, but in fact you can just add another vector that is only affecting the y-axis. Okay, so in the output the point will change, so we're gonna give there a float to vector, and the x would be the same, the z would be the same, and the y value is the value from the beginning. This is the actual value, and I want to add another value that is the offset. Then the added value will be the new value. Okay, so now I want a ramp parameter. Ramp parameter, that's a magical tool that you can edit colors, gradient colors, but also you can switch that ramp node to the spline ramp that you can now edit float value over 0 to 1. 0 to 1, okay, but I have 8 points, so I want my point number divide my number of points to have in a percent way the number in a percent way. So as we have int, if I divide int by another int, I will have an int output, so it will stay 0. So I have to convert by a simple trick. I will multiply by 1, a float by 1, so the node will become like this one, that green color. That means that it's a float. So I can multiply that point number right here by no, I can multiply the constant by the point number, so the output will become green, and I will divide that value by the number of points. So I will give divide, and before that I will because the first index is 0, I will subtract 1 to the number of points. So there you have the point number, that is everything happening right there is a loop. So this node network will be applied to each point. So first point, point 0, point 1, until we reach point 8. Okay, so the number of points right there is subtract. I subtract 1 and I divide the point number by the total number of points, and this gives me the value I need, that is that its range is between 0 and 1. Perfect. So I just plug it into my ramp and plug the output of my ramp in the add node. So what's going on there? Here is the point number on the horizontal axis. Vertically I can draw the values that will be that will go in the output, and that will be added to the start position y, because don't forget I use only the y axis here. Okay, donc the point number divided by number of points. Okay, the constant is 1. Okay, so I can go back go back from the inside of my point VOP, clicking right there on bridge, and now I have my ramp, and as you can see I can sculpt easily my bridge. I will go with a very simple curve, so I'm just adding a point there, putting right in the center, .5 position, and the value. And as you can see, I have straight lines and I want a curve, so the interpolation of right there in the curve editor can be changed right there, interpolation. I could use a catmull, add catmull spline definition, Bezier, B-spline, or stay linear. Okay, let's go on the Bezier. Everyone go Bezier and Bezier. Right now I have my curve. I can edit this value, push it, make my bridge flat. I can go negative. Okay, I can go negative this way. Okay, let's give maybe like this. And it's time to save, because Houdini is quite stable, but I'm gonna make a folder that is bridge demo, and the file is also bridge demo. Okay, so there I have my the very beginning of my my bridge. Many things I could many ways to make my my floor from this curve. You can maybe add some wood planks. That would be fun. That's better than a simple surface. So how I could do that? I can make a resample, another one. So this one is to decide about the number of planks, of wood planks. And maybe it's the same. I would change the maximum length, segment length, to maximum segments, and maybe I want 21 points or 21 wood planks on this. So first concept is seen, has been seen. It's the curve. That is the best way to start procedural things. Second is the copy 2 points way. It's very simple, but how do you do that? You have many points. You can copy on those points entities. So you just have to make a copy 2 points. On the right there you have to plug the points, and on the other side the object you want to copy on these points. I will copy a grid that is a simple flat polygon. The grid is by default quite subdivided, 10 by 10. Let's blue click to preview that. So this is the grid. I don't want so many points. I will go with game ready asset. So let's make something 0.01, point 10, apply. So the default value will be 10. You can change the range and lock the range if you don't want people to go 100. 0, apply. So you can go from 0 to 100, but you can say, you can type 1000. Sorry, you can type there 1000, and the value is not locked. It's not constrained. To constrain, just activate. Just click on the locker right there, or the minimum value and maximum value. Very simple. Okay. Okay. Let's go faster on the second control, the ramp. So maybe you can decide to go on this node to control the ramp, or have the ramp right there in control used in this node. So I have to make a ramp float parameter, that ramp shape, maybe default interpolation into Bezier. You can make default points, whatever you want. Let's go faster on this one. So apply. Now I have my ramp, and maybe accept. and let's give a try. Now nothing is working because parameters are not yet linked. To link my parameter, I just click on ramp shape, copy parameter, I go in my curve control, ramp, paste, relative, reference, and as you can see, everything come now from my initial controls parameter. So now I can go into my control and make my shape again. Dot 5 in the middle of the bridge. The value is, I don't know, maybe like this. Okay. So now I have my curve control on the control on the top, and everything will be in this node. Very simple to modify your asset. So the same for initial curve segs, copy parameter, resample, segments. You can also delete the value and paste inside, paste relative reference like this, and now it should be working. Yes. Okay. Save, and let's go further. If you want to make the ramps, you can go into another network, maybe right there, and you can move later. Maybe we want to resample one more time. So resample. So you can decide the number of segments, maximum segments. Oops. Right there. Okay. Now I will extrude my spline, or maybe I could maybe I could copy it before, depending on what you want. Maybe you can just work on this one and then copy or mirror this thing for the other side of the bridge. So you can make the copy, the mirror on at the beginning or at the end, whatever. I will go with a mirror at the end. So let's make a single ramp. So resample. Okay, extrude, poly extrude, poly extrude. Value. So this is the 8 of the sides. Okay. What I can do right now is make a new controller, new parameter that is linked to this one. Maybe I will, if you understand the process, you can go. I will make it for this one, but you can do it for whatever you want. So if I want to go back into my panel controls, I can right click, parameters and channel, edit parameter interface. Okay, let's add a float value that will control my extrusion. So this is a float. Oops, float value control. I can call it sides 8. And it apply, and maybe give a default value 1. Apply, accept. Right now I have side heads, right click, copy parameter, poly extrude, distance value, delete the value, right click, paste, relative reference. Okay, so now in my controls I can change this value. I can scroll click and change the value range, the value increment. Sorry for so bad, so poor English. I do my best. I do my best. So let's continue. Something very interesting right now. I want to give shapes, special shapes, and to give special shapes, I will iterate. I will do a loop on each primitive. There, I have some primitive, the faces. I can display the primitive numbers right there with this button, and I have 6 primitives. Okay, for each primitive, for each one, I will like making a cut, but I don't want to really cut this. I will go into a shape that is that will use voronoi. Voronoi is very useful not only for breaking glass, wood, or breaking everything into rigid bodies, but very useful to make pattern design. So this is the very interesting point of the tutorial. I will go save and let's iterate with a for loop. Just tab for, just use the for each primitive. When you are not sure, you can check the blue for each end and see that the iteration has been done 7 times. That's it, because the first is 0. I have 7 pieces. Okay, perfect. For each one, if I click there, I see the first iteration. I can go on my loop and check single pass and check each of my iteration. But the nodes I will make between those 2 oranges node inside the loop, all the node that I will connect right there will affect the same process on each primitives. Very simple. So for each primitive, what I will do is extract centroid. I want the center of the face. Okay. I don't tell you much. You will understand in a few seconds. So there is a very interesting node that is called extract centroid. As I connect this node and blue click to visualize, I see an error, a problem, because it's running over piece. I need to run over detail. So right now I have my blue points, that is the centroid. If I visualize the primitive, the face, I see it's the center of mass that is used to that is used for calculation. That's okay for me. It gives good results. On this point, I will copy. So I will copy 2 points. I will copy whatever you want, but let's give a try with a cycle. So I have a cycle copied. It's very big. It's very, very, very big. So let's scale it down to this, and orientation should be the same. Okay. So the orientation might be the YZ, like this. That cycle is by default a primitive. I want to use it as polygon with points, as you can see, and I don't need so many points. Maybe this. In fact, you can try whatever you want. Okay, let's try with some few polygons, but you can change everything, and everything will have different results. So now I want to merge my points from the original face with these new points. So merge is a node that can make all the points together, right? And the original face will be broken, will be fracture voronoi. Voronoi, I can go with a voronoi fracture. So this face will be cut with these points. And here we go. You have this pattern. That's very cool. I think I forgot something. I didn't merge. Okay, so that's better to merge the extracted point. In the merge, I don't have the center points. The first node that I use, that is the centroid. I want to add the centroid in the cut, so I will have a better pattern like this. So now I can change the cycle size. As you can see, it gives me different shapes. The cycle, so many things to change. The cycle number of divisions, maybe, or whatever you want. And at the end, we could, as you can see, the for loop executes the same pattern on each primitive. That it's adding a cycle on each primitive, add the centroid, merging, and voronoi. That's it. I will go over a fuse that will fuse, as it said, all points that are at the same position with a snap distance, there, threshold. Okay. Now I can build the visual aspect with at this time there are many ways to do this. Also, you can go easily with simple poly wire, poly wire, right there. Changing the radius, smallest radius. Okay. The color is black. Okay, we saw at the beginning that a light gray is polygons normals that are flipped, inverted. The dark means there is no normal information. You can change this just applying a normal nodes that will calculate normal, and you can change the angle right there. So as you can see, the use of voronoi is very interesting to make design patterns. I can change everything. Maybe save before. Okay, I can go on my cycle. I can use noise. I can noise my cycle. I can scale it. Look, if I scale my, wow, this is great. I love all the things you can achieve with voronoi. And this is very simple example. In fact, it gives you infinite possibilities. Okay, now time to save, time to name that network, that part of the network with the network box, and this is sides. I have to link the offset of the sides to the there. You have to remember that the planks, the width is right there. So the width of the bridge do not exist yet. Let's create it in a new parameter in my controls. So right click, parameter, edit parameter interface. Let's give it a float. Let's name it bridge width. Bridge width, and default value 0.5. Apply, accept. Bridge width, right click, copy parameters, use it in the grid. First size X, paste relative reference. So now I can, whoops, so now I can, oh sorry, I can control the width, and this is the same value that will be used to offset my side right here. So I can transform to move my geometry. I want to translate on the x-axis from the same value divided -1. Now the normal are inverted, so the copies point right now in the good direction. Okay, the line is a bit it's a bit too long. It could be the same 8 as the extrusion of my sides. The extrusion that is the control side 8. I can copy this line and use it as the line length. So everything is procedural. I can add an offset. Maybe it's this value, linked value. Add more dot 1. Maybe you can do almost everything you want. So copy 2 point. Okay, the line should be now a geometry. You can use maybe the sweep. As I said, the sweep is like a polyline, but giving you many options. The sweep can be a shape you define first, but it can be a simple shape like a round tube. You can change the number of points. It could be a square tube with subdivisions also, like this. Maybe let's go with a round tube with it's game ready asset, so maybe 6, maybe 8, but not with thousands of faces. Okay, this is the pole width, the radius. Let's save. Let's hide normals, point attributes. Let's merge this. Let's alt click to give a clearer network. So if I display my merge, I can see my poles right on the curve. They need the same here. They need the same mirror and the same transform, so I can add them to my original side with a merge, so that the transform and the mirror will be applied to the group. So I can press Y and cut and connect this to the merge. Right there. Right there. Okay. This time also polygons appear black, so we need, you may know, there is no normals. Oh, maybe you can tell the sweep to calculate normal. Construction. You can compute UVs, very interesting. You will have for complex shapes, you have clean UVs at the beginning. I don't know where is that thing, so I'm sorry, but I will go on a normal node. That will be perfect. So the sweep is maybe too big. The line length will be the same as the extrusion. Okay, the sweep will be closed, so I go in because as you can see the tubes there are open, so you can go on end caps option, simple polygon maybe, and go with sculpting procedural pole. So before I will reduce the width. Okay, I don't go adding that radius value in my controls, but you should do this. It's the same as we saw before, so I will go further with something more interesting maybe. As you can see there, my line and my sweep is vertical, so it stay clean to be modified before it is copied using the normal. Very interesting, so that I can use the face on top. How to make it procedural? I can select this face. Okay, right now I go into a selection mode on my sweep and select this face and extrude or whatever. But that's not procedural. If I want to be procedural, I should go on a group that is making a selection. How can I identify this unique face? It's quite simple. This face is the only one in my topology to look up to the top, to the y-axis positive. So I can select a face by its normal using the keep by normal, using the y-axis x, y1, z, 0, and that's all. Now my face, my top face, is selected procedurally. So what can I do with this? I can also, let's show you something simple but efficient. You can go with an extrude, poly extrude, and this extrude is applied to my group. So maybe I give a better name. I call this top group. So my extrude will use the top group, the extrude value, maybe whatever, like this. And you can add subdivisions, maybe 6. Why adding subdivisions? Because you can sculpt, like extrude along spline, that is implicit in Houdini. You can sculpt the shape using the spine control. That can use a ramp that could be set in the controls. Let's give a try. Controls, parameters, edit parameters, ramp. We will use a ramp float. Called it pole top shape. And that's it. Apply. Accept. I will use that shape, right click, copy parameter, in that thickness ramp, click, right click, paste relative reference. It's okay. Now I can go in my controls and sculpt the top pole, maybe like this. That is a simple example, but showing many possibilities from this. I select this, I call it, I create a network box and I call it poles. Okay, that is copied right there. That is mirrored right there, and that is merged at the end. A last thing would be a structure that is hanging and supporting the bridge. As you can see, you can go voronoi many times. You can go voronoi is very great. It's amazing tool. So what we can do here is go from the shape that is supporting the planks, that is that resample node, and go into another calculation. So I can close my shape with ends. I don't remember. I think it's U. If I use a close straight, it should close my shapes. Perfect. Now I have my closed shape. Based on the previous shape, based on the curve, based on the line. That is fully procedural. That's important that everything comes from the original shape. Save. Okay, so now I have that shape. I can go as I did before with centroid. Added to the shape with a voronoi. Maybe it's the. Whoa. Let's give a try. Voronoi give very interesting results. So I would go on extract centroid. That gives me with a detail. That gives me that point right there. That is the center of mass. I can use the bounding box center if I want to change the calculation. I can use that point to make a copy. What can I copy? I can copy whatever you want. Maybe I use a square. I use the cycle at first time. Maybe I could use a square this time. Or the cycle is logically, it will distribute like sun rays, and to make the structure, I think it's the more logical. The cycle is copied on the extract points, so I will use copy 2 points. Let's plug, copy. Let's orient the cycle on the YZ plane. Okay. Scale it down. Or don't scale it. Maybe you want weird results, maybe you can transform. Maybe you want to transform the cycle to move it down, up, to change the shapes. It gives you a better control. But at the end, the result will be used to make a voronoi fracture on the original shape, like this. Oh, what's going on? What's going on? I don't know. Close straight. Okay. Voronoi. Copy to. Okay, maybe I'll let the cycle into the primitive. In fact, voronoi need points, but the primitive do not output points. I have to go into the primitive and change polygons. Right now, it's okay. So I can move up and down my sphere. You can see the different results. You can change your sphere, your cycle, sorry, your cycle size. Well, I don't know. Oh, it's very small. Okay. I forgot to add the centroid to the points. I can merge. Whoops, not a file merge. Sorry. I can merge the voronoi points with this one. It gives me like architectural structure. Okay, so change the scale, the cycle radius, change the scale, change the position of the cycle. Gives you everything, not everything you want, but a very interesting way to explore design and patterns, as I said before. So now I think it's okay. Okay, I want to keep some of the edges, but not all of them. So I can use selection, group selections, or simply use a sweep directly. If I go into a sweep, I may have some few problems. Let's give a try. If I sweep with maybe square tubes like this, very okay. I have with sweep these problems of overlapping faces. As you can see, maybe you see the edges that are flickering right there because faces are overlapping. That's problem with sweep and complex structures. So if you have this kind of problems, you experience that kind of overlap, you can go with Poly Expand 2D. That is very powerful also. Let's okay, so you can go from your voronoi, fuse points, something maybe interesting things to do with voronoi is also using the cut plane offset right there. I don't need it at the moment, but it can make additional shapes. Okay, 0. Okay, so fuse. Now use expand poly with the offset surface mode activated, keeping the inside geometry, extruding it with the with the output back checked, and bring it back. It normals. Okay, and this is something that will be merged with sides, so I can push my node tree on the other side. Like this, and Y, cut the wire and plug the normal into the merge, so everything like this will be transformed and then mirrored. So right now my bridge looks like this. I can now shape almost everything. Many controls are missing. If you understand the principle, it would be very easy for you to make something simpler. So I have the first thing first. Oh, yeah. Number of segments subdivision for my bridge. I can go with something very straight, very smooth. I can edit my curve with something coming to from 0. Whoops. What did I did a mistake? I don't know. Okay, position value. Whoa. Okay, I can go into 0.0001. Okay. I don't know, maybe Bezier, and also Bezier. There is something strange right there. Curve control. Let's see. Point number divided number of points, subtract 1. Okay, ramp. Okay. Okay, maybe I didn't let enough. Maybe I didn't let enough points. 0.01 dot 0.01. Oh god. Still problem with poly expand right here. Calculation is weird because of that curve. Okay, let's go back to the curve control. Let's change the curve to monotone. Monotone cubic. Okay. Okay, one of the points was still in Catmull. Okay. So sorry for this. I can make a color for my node control, and now I can sculpt my bridge with that node. Everything is procedural. The sides, the height of the ramps, the width of the bridge, maybe 10. Oh, I give a side. I didn't give an integer. Okay, integer, sorry. So size number, okay, with 10 as default value. Okay, let's apply. Bring it to another screen. go back into control. Let's go into the side number, copy parameter. Let's go into the side resample node and segment paste relative reference. So now I can control my sides of this parameter. Okay, I have the width. I do not have the length parameter. So let's go back there. Let's go with a float, a simple float value. I have the width. I also need the bridge length. Bridge length as a name and also as a label, and maybe give it a default value of maybe 1. Apply. Go back into control, bridge length, copy parameter. Let's go into the line length, paste relative reference. So now I can stretch my bridge. Maybe I could scale the curve. That's interesting and very simple thing to do. So the curve is defined by the point VOP curve control. Here is the curve, and I add that value to the Y position. So there I can multiply that value before adding it, multiply by a parameter that should be maybe a scalar. Oops, the ramp is multiplied by the scalar, and the scalar has the default value of 1, and the scalar there will be controlled by my main interface. So control. Let's give a float, maybe just before or after the ramp shape, and call it ramp, maybe scale. Maybe default value of 1. Apply. Go back into the panel, into the ramp. Under ramp we go ramp scale, copy parameter, use it in the curve control, scalar, paste, relative reference. So now I can scale the entire curve in an easier way. It's really nice. Okay. My curve control is right there. My top shape is it's okay. I don't have a pole width parameter, so I could add it. I can make another tab inside control. I can make another control panel. So much things to do. It's very powerful. But let's stop this example with the last thing, maybe the float. It's always the same. The float we can call the pole radius. That have a default value of 0.1, and apply, accept, all top 8, copy parameter, and use it as the extrusion value that is right there, distance, paste, relative reference. Okay, so now you have all the controls you need to make a pole shape you can change so the extrusion value, the radius of the, oops, sorry, you have to be gentle with this one. Okay, that's it, that's all for that bridge. I hope that you learned something with that that small tutorial, and see you later with this great tool that is Houdini. Thank you.